Welcome to today's lesson 4.2, modeling with linear functions. And our first learning objective for today will be build linear models from verbal descriptions. Building linear models from verbal descriptions. When building linear models to solve problems involving quantities with a constant rate of change, we typically follow the same problem strategies that we would use for any type of function. Let's briefly review them. So first we want to identify changing quantities and then define descriptive variables to represent those quantities. When appropriate, sketch a picture or define a coordinate system. Okay. 2. Carefully read the problem to identify important information. Look for information that provides values for the variables or values for parts of the functional model, such as slope and initial value. 3. Carefully read the problem to determine what we're trying to find, identify, solve, or interpret. 4. Identify a solution pathway from the provided information to what we are trying to find. Often this will involve checking and tracking units, building a table, or even finding a formula for the function being used to model the problem. 5. When needed, write a formula for the function. 6. Solve or evaluate the function using the formula. 7. Reflect on whether your answer is reasonable for the given situation, whether it makes sense mathematically. And then 8. Clearly convey your results using appropriate units and answer in full sentences when necessary. Okay, let's look at example 1. Using a linear model to investigate a town's population. A town's population has been growing linearly. In 2004, the population was 6,200. By 2009, the population had grown to 8,100. Assume this trend continues. A, predict the population in 2013, and B, identify the year in which the population will reach 15,000. Okay, so we're doing, let's see here, town's population been growing linearly, so we know we're going to do a function. Let's do population as a function of time. Is going to be some, I almost put mx, t would be the x plus b. All right, so we're given, let's see, town's population 2004, so t would be your x. So we have 2004, the population was 6,200, and 2009 the population was 8,100. So we need to figure out m using that those 2 points. Okay, so we plug it in our formula, m y2 minus y1 over x2 minus x1. So we get 60, we'll go, this would be 0.2, that would be 0.1. So 8,100 minus 6,200 over 2009 minus 2004, which would be 1,900 divided by 5, which gets us 380 people per year. Okay, so that's our slope, or rate of change. Okay, so let's see, we did that. We converted the data to coordinate pairs. We found the slope. Now we want to write the linear model. So we're going to use this linear model to make a prediction. So we found M, we got to figure out B. So a couple ways we can do it. We can call T, let's see here. If we say linear, okay, so what we can do is we can shift this and we'll call this times 0. So T equals 0 is equal to the year will be 2004. So T equals 5 would be, then you just add 5 there. 2004 plus 5 would be 2009. Okay, so we can change this to 0 and 5, which is not going to change the outcome because 5 minus 0 is still 5. All right, so now we can write the equation. This would be our y-intercept, 6,200. So our formula or linear model would be population as a function of time would be 380 t plus the initial value was 6,200. Okay, so now we have that. Now we can use the model to make predictions by evaluating for the given x, or in our case t. So 2013, so t equals what for 2013? So we just have to subtract 2013 minus 2004, which will get us 9. So P of 9 would be 380 times 9 plus 6,200. Just punch this in your calculator. So let's see here. 380 times 9 plus 6,200 is 9620. All right, so predict population. So this would be 9620. And then identify the year in which the population reaches 15,000. So we want the population to be 15,000 and find the t that gets you 15,000. So we're just going to solve this equation for 15,000. So we subtract 6,200, and that will give me 8,800, and then divide by 380. So t equals, I don't know why I didn't bring up this calculator. Let's see, 880 divided by 380 equals 23. So about 23 years. Do we want to round it to the nearest year? Okay, it's a little more than 23 years. 23.1, whatever it was. Okay, so identify the year in which the population will reach 15,000. So in year 20, okay, so 23 plus 2004 would be 2027. So sometime during that year, right? In 2020, the population will reach 15,000 people. Example 2, using a diagram to model distance walked. Anna and Emmanuel start at the same intersection. Anna walks east at 4 miles per hour while Emmanuel walks south at 3 miles per hour. They are communicating with a two-way radio that has a range of 2 miles. How long after they start walking will they fall out of radio contact? All right, so we need to make a little diagram, see what's going on here. So we're at some intersection. Basically, let's just do, we got this. We're starting here together. Anna walks east, north, west, east at 4 miles per hour. So basically, Anna's walking this way at 4 miles per hour. And Emmanuel's walking south, so this way, at 3 miles per hour. Guess my line would be shorter. 3 miles per hour. Now remember, distance is equal to rate times time. So this distance is going to be 4 times t, and then this distance is going to be 3 times t. And we want to know when the distance apart, we'll call that we'll call it C, right? Because this is Pythagorean, the Pythagorean theorem we're going to use for this right triangle. So a squared plus b squared equals c squared. So we'll call that A, we'll call that one B. So C is their distance apart. And they want to know when are they going to be 2 miles apart, right? Because that's when they're going to fall out of radio contact, because the range is 2 miles. So we want to say C has to be, when is C equal to 2? So we know that A squared plus B squared equals C squared if this is a right triangle. So we get 4t parentheses squared plus 3t parentheses squared equals c squared. We're going to plug in 2 for c. So 16t squared plus 9t squared equals 2 squared, which is 4. And then that'll be 25t squared, combine like terms. And then we're going to divide, we want to solve for t squared. So if we get the t squared by itself, we can square root both sides. Square root, and since it's the geometry, we can throw out the negative. We don't need to do plus minus. So t equals square root top, square root bottom, 2/5. And remember that t, we were doing miles per hour. These were hours. So 2/5 of an hour, or what's 2/5 times 60 minutes? So the hours would cancel. So we get 120 divided by 5, which is 24. 24 minutes. Okay, so now we'll answer the question. When do they fall out of radio contact? So they will fall out of radio contact. Oops. Contact in 24 minutes. Example 3, using a diagram to model distance between cities. There is a straight road leading from the town of Westboro to Agritown, 30 miles east and 10 miles north. Partway down this road, it junctions with a second road perpendicular to the first, leading to the town of Eastboro. If the town of Eastboro is located 20 miles directly east of the town of Westboro, how far is the road junction from Westboro? Okay, so let's see. We have, there's a straight road leading from the town of Westboro to 30 miles east and 10 miles north. Okay, so let's see here. If we think of this like on an axis, we want to go 30 miles east, and then 10 miles north, say something like that. This would be and we have a road going straight from the one to the other one. So this is Westboro. This is Agritown. Partway down this road, it junctions with the second road that's perpendicular to the first, leading to a town called Eastboro. The town of Eastboro is 20 miles directly east of town Westboro. So right about here, right, 20 miles is Eastboro. Oops, spelled that wrong. Let's see if I can fix it. Eastboro. And it has a road that is perpendicular, so something like that. And how far is the road junction from Westboro? So we want to find, so the key here is they told us is perpendicular, so they want us to find this distance here from Westboro to this junction. Okay, so if this is 3010, what is this one? We have what we call similar triangles. We can set up a proportion. We can also figure out the slope of this. So if this is 10 and 30, this equation would be, let's see, there'll be rise over run. Okay, so we're going to, again, we're going to introduce this as a, like an XY axis, actually. So here's X, and we can put, this is arbitrary, right? So we can put our axis anywhere we want. So on this red XY axis, Agritown is at the point 3010, 3010, and Eastboro is at the point 20, 0, and then we want to find out what this point is here. So this equation for the line from Westboro to Agritown, we can use this, we'll call it W of X, and the slope is 30 over, its rise is 10 over change of Y over change of X is 30 over 10. Oh no, it's the other way around. 10 over 30, which is 1/3. Okay, so that's the equation of that line. Now we're going to find the equation of this line, which we'll call E of x. So E of x would be, if it's perpendicular, then the slope is the negative reciprocal. So that would be -3, and then plus b. So now we're going to plug in 0, 20 to figure out what b is. Or 20, 0. Oops, I did that backwards. So this would be 0. -3 times 20 plus b. So that's -60. Add 60 to both sides, so b is 60. Okay, so this equation for east borough is -3x plus 60. Now that we have both of those equations for both of these lines, to find the intersection point, we just set them equal to each other. So that equals that. So the Westboro line is 1/3 x, and then the Eastboro line is -3x plus 60. We solve it. So we add 3x to both sides. So 3 and 1/3 would be 9. 10/3 x equals 60. Then times the reciprocal. 3's cancel, 10's cancel. So x equals 180 divided by 10, which is 18. So if x is 18, then you can plug it into here. If x is 18, and then 18, and then y would be 6. So now we can find, oh, that's not x anymore. It was x before. Now we can find the distance using Pythagorean theorem with these 2 points, because on the xy axis from here to here is 18, and this would be 6. So this distance to the junction is going to be the square root of, we're going to do 18 squared plus 6 squared, which will be about, just punch this in your calculator, which will be about 18.974 miles. Okay, so that junction is 18.974 miles from Westboro. And the last learning objective, model a set of data with a linear function. Modeling a set of data with linear functions. Real-world situations including 2 or more linear functions may be modeled with a system of linear equations. Remember, when solving a system of linear equations, we are looking for the points the 2 lines have in common. So typically, there are 3 types of answers possible, as shown in figure 5. Okay, so if we have intersecting lines, they intersect in exactly 1 point, that's going to give you exactly 1 answer. If the 2 lines coincide and they're actually the same line, every point on the blue line and every point on the red line would be the same. And then you have infinitely many solutions. And specifically, any point on the line would be a solution, not everything. So for instance, if I had a point over here, this point's not on the line. So the only thing, there's an infinite number of solutions. I used to not understand this when I was a student. I used to say, oh, it's all real numbers. No, it's all the points on the line, right? So if it's on one line, it's on both lines. But this point over here is not a solution. because it's not on that line. And then if you have parallel lines don't intersect, so they won't have any points in common. So this would have no solution. Building a system of linear models, choose a truck rental company. So this is example 4. Jamal is choosing between 2 truck rental companies. The first, Keep On Trucking Incorporated, charges an upfront fee of $20, then 59 cents a mile. The second, Move It Your Way, charges an upfront fee of $16, then 63 cents a mile. When will Keep On Trucking Incorporated be the better choice? Okay, so our situation here has 2 different linear models, one for each company. So our first step is going to identify the input and output of each linear model. So we want to figure out the total costs would be our output. And it's going to be cost per mile. So X would be, so we want costs as a function of X. X being our number of miles we drive the truck, and C of X, that would be the output, which is the cost. Okay, identify slope y-intercept each model. So for the Keep On Trucking, we'll say it is $20 upfront fee plus the rate of change is 59 cents per mile. So 0.59x. And then Keep On Trucking, we probably could use, I'm going to put a C sub K for, and then the other one, Move It Your Way. Their cost, I'm going to put a C sub M, is going to be $16 for your upfront, but 63 cents per mile. Okay, so now we're going to find a solution by setting the 2 linear functions equal to each other, solving for X. So we're going to do 20 plus 0.59x is equal to 16 plus 0.63x. So let's see, we're going to subtract 0.63x, and then so I'm getting the x's on this side, and then I'm going to subtract 20. Probably should have done it the other way. Okay, 0.59 minus 0.63 would be negative 0.04x. 16 minus 20 would be negative 4. Then I'm going to divide by negative 0.04. So x equals 100. So let's see. So if I did 100 miles, they'll cost exactly the same. So let's just check that. C sub k of 100 would be 20 plus 0.59 times 100, which would be 59, plus 20 would be $79. And then C sub m of 100 would be 16 plus 63 cents times 100, which would be $63, plus 16 would be 79. So you see that's equal. So if I now, when will Keep On Trucking be a better choice for Jamal? So he has a bigger upfront fee but less per mile. So if you think of it that way, if I were to do 200 miles, you'll see this one would be cheaper than this one. So basically anything more than 100 miles, Keep On Trucking's the better deal. Anything less than 100 miles, you want to do it, Move It Your Way. Okay? So if you did 0 miles, you see this one's $20, this one's $16. So this would be the better deal. So if I were to do an XY axis, Keep On Trucking would be starting at 20 and go like that and move it would be at 16, and they intersect here. So from, this is 100, so anything that's more than 100, this one's going to cost more, the move it your way, and keep on trucking, it's going to be cheaper. But if it's less than 100, it's the other way around. The keep on trucking is going to be more expensive, and move it your way would be cheaper. Okay, so let's see. So when will keep on trucking incorporated be? So keep on trucking is a better deal when Jamal has to go more than 100 miles to drive more than 100 miles. Okay. All right, that brings us to the end of the section. So again, practice, practice, practice. Do as many of those odd exercises and you can. Do some even ones if you feel like it. And I'll see you next time.